Young's modulus. For us to understand and calculate or express Young's modulus, we need to first understand two terms: stress and secondly, strain. Let's start by stress. Stress is defined as the force applied by unit cross-sectional area of the wire. Therefore, stress is mathematically expressed as force over cross-sectional area. Strain. Strain is expressed as the extension of a material or a wire over the original length. Let the extension be x and the original length be capital letter L. Therefore, strain is equal to x over L. Strain is a ratio and therefore it has no units, while stress is expressed in newtons per square meter or pascals. Therefore, Young's modulus is the ratio of strain to stress of the material. Young's modulus is equal to stress over strain. Let stress be denoted by sigma and strain be denoted by epsilon. Therefore, Young's modulus E is equal to sigma over epsilon. Worked example, Young's modulus. The question reads, a sample of fishing line is 1.0 meters long and is of circular cross-section of radius 0.25 millimeters. When a weight is hung on the line, the extension is 50 millimeters and the stress is 2.0 times 10 to the power 8 pascals. Calculate A, the cross-sectional area of the line, B, the weight added, C, the strain in the line, and lastly D, the Young's modulus. To solve this, we can start with the first question, the cross-sectional area of the line. Since it's circular cross-section area is calculated as pi r squared. Therefore, we use pi times the radius squared, and the radius is in millimeters, so we need to change from millimeters to meters. That's by dividing by 1,000. We can now square and multiply by pi. So our cross-sectional area is 1.96 times 10 to the power of -7. Number B, the weight added. Weight is given by stress times area, that is sigma times A. Stress was given as 2.0 times 10 to the power 8, and area is the value we obtained in A, which was 1.96 times 10 to the power -7. Therefore, 2.0 times 10 to the power 8 times 1.6, 3 times 10 to the power of -7 should give us 39.3 newtons, which is approximately 39 newtons. Number C, the strain. Strain is calculated as extension over length, extension x, length L, therefore strain is x over L. And according to the question, extension was 50 millimeters. Therefore, we need to convert the 50 millimeters to meters by dividing it by 1,000, which should give us 0.05. Therefore, 0.05 divided by 1, we still retain our answer. And therefore, the strain is 0.05 as a percentage. It can be written as 5%. And then lastly, number D, the Young modulus E is expressed as the stress over the strain, and therefore we got to take 2.0 times 10 to power 8 and divide by the strain we obtained in C, which is 0.05. 2.0 times 10 to power 8 divided by 0.05 is equivalent to 4.0 times 10 to power 9 pascals. Just remember that all the physics units must always and at all times be given in SI units unless stated otherwise.